we have here is a little bit of water being heated up in a can. It looks like there's a bit of steam coming out. It's not actually steam, you can't see steam, but it's tiny little droplets of water that have been heated up. So what we're going to do is invert this into the trough of water. This is just an example of a physical change. And you'll note we had a pretty quick implosion of the can. Nice little crushing going on there. What a lot of people think was that because it was put in the cold water, it got cooled down. And we know that when you heat something, it expands. When you cool it, it contracts. That is not what's going on here. If we had a nice plug the shape of the opening of the can, we wouldn't need the water at all. We could just plug up the hole and we'd get exactly the same thing. The can would implode. What's actually going on is all about air pressure. When we were heating it, the particles inside the can were getting more energy, they're racing around, we were losing some water vapor out the top. It was low pressure inside the can compared to what's outside. But it was an open system, so the can wasn't being crushed. By putting it upside down in the water, it's not that we were cooling it down, but we were closing the system. We were plugging up the hole, in this case with the water. Because we now had low pressure inside the can, high pressure, relatively high outside the can, just from atmospheric pressure, there's a force from high to low pressure, so the can was pushed in. The atmospheric pressure is all that was required to squash the can, because it was lower pressure inside.
Oh.